Good evening, my dear students. Welcome to HashLearn Studios. My name is Dheeraj, your chemistry teacher for the day. And the topic under discussion today is part of the lecture series belonging to coordination compounds, which is again part of JEE and NEET lecture series. And the topic under discussion is bonding in coordination compounds, guys. So let us quickly get into the class. So to quickly recap the previous classes concepts, we looked at VBT theory, that's valence bond theory, and numerical problems to do with valence bond. And like you guys know, I look at cumulative concepts. So we will be looking in today's class as well. We will have problems based on bonding. Apart from bonding, we will also have problems to do with what we have studied so far. So it's going to be a cumulative study. So proceeding, the important CPP question picked up from the list of questions that were given to you in the previous class. So the charge on cobalt in the given complex COCN minus 3, COCN4, 3 minus. It's a simple, like I have mentioned there, it's a simple algebraic sum. So all that you have to do is take cobalt's oxidation number as unknown and cyanide is minus 1. So unknown plus minus 1 into 4 is equal to minus 3, and you have the oxidation number in front of you, that's plus 1. So we have Sakshi and Yogesh, Sakshi Pandey and Yogesh joining us as of now. Good evening, guys. Welcome to the webinar. Let's get going. Like I said, today's class's goal would be to look at coordination compounds bonding, and apart from that, to give you guys a holistic approach of whatever we have looked at so far. So that's how it's going to be today's class, as well as whatever we have studied before that as well. So the next slide that you would be seeing is the first question for the day. Let's get going, guys. So the first question, I've kept it pretty straightforward. Oxidation state of chromium in give me a moment here. We will take this a little later. Look at this question, guys. Look at this question, because if you look at these, it'll provide a recap for you. Then that question that I'll be giving next would make more sense. So look at this question really fast. The IUPAC name of NH3 4 times NiCl4. We'll get back to that question, no worries. So let us get going with these first. So try to answer. Tetrachloronickel 2, tetraamine nickel 2, tetraamine nickel 2, tetrachloronickel 2, tetraamine nickel, tetrachloronickelate. Simple. You just have to figure out which among the two is a cationic complex, which is an anionic complex. Once you have an idea as to which is the cationic complex and which is the anionic complex, the rest becomes very easy. So Sakshi says it's 1A. So Sakshi is assuming you can prefix the questions with this question number as well, since we have skipped that question, so that once you get a detailed idea of whatever doing in today's class, we'll get back to that. You can prefix your options with this question number, guys. So Sakshi says it's A, Yogesh, okay, both of them say it is B. Fine. So IUPAC name of NiNH3 4 times, guys, think once again. The IUPAC name is option C, tetraamine nickel tetrachloronickelate. I've told you guys before as well, you have to name the cationic complex first. We're pretty much looking at it in all classes, guys, so that this is exactly why I look at cumulative questions, so that you don't forget what we have looked at in the previous classes. So cationic complex is named first, followed by anionic complex or anionic coordination sphere. So if you look at this, the charge on amine is 0. Therefore, go to this. Charge on chlorine is minus 1. Minus 1 into 4, minus 4. And therefore, nickel will be in its regular oxidation state, which is plus 2. Therefore, this is minus 2. If this is minus 2, just give us a minute here, guys. Give us a minute here. Yes guys, that was a small technical glitch from our end. So what I was trying to tell you is we name the cationic complex first and then we try to name the anionic complex. This is the cationic complex, this is the anionic complex. Cl is -4. Therefore, if we take the regular state of nickel oxidation state, regular oxidation state is +2. Therefore, the overall state is -2, which means if this is the anionic complex or the anionic coordination sphere, this has to be +2. If it is +2, I know that amin's charge is 0. If amin's charge is 0, nickel's charge has to be +2, which means it is tetraamine nickel with coordination number 2. That's the oxidation number 2, and tetrachloro or chlorido in some cases, tetrachloronickelate, because it's an anionic coordination sphere with oxidation number 2. It is option C. So Yogesh says C, but guys, yes, these are very simple things which I have helped you guys look at in a couple of classes. So you have to be able to give us the right answer in the very first go. So looking forward, I have quite a few questions packed like this. So looking forward for right answers in the forthcoming class, in the forthcoming questions, guys. So let's get going. The formula of sodium nitroprusside. Formula of sodium nitroprusside. What is it going to be? Quickly. So shouldn't take you too much time. Sodium nitroprusside. So Yogesh, try to prefix the answers with the question number, guys. And people who have joined us through YouTube, welcome to the webinar, guys. We have Shakir joining us. Shakir says hi. Yes, Shakir, hi. Hope you are enjoying the webinar. It is quite enthusiastic as well as informative. So have a detailed look at our webinar. So Shakir says it's A. Okay, guys, we have got the answer from one of our users, students, and then waiting for your answer, Sakshi and Yogesh. What is it going to be? Formula of sodium nitroprusside. What is it going to be? Okay, let me give you the answer, guys. It is option A. Where do I use this sodium nitroprusside? I've told you in a couple of places before as well. Sodium nitroprusside is a coordination complex. It can be used in coordination compounds just like how I've used it here, or it can also be used in the general organic chemistry chapters, where I can ask you that this complex is used in the detection of what? This complex is used in the detection of sulfide ion. So the moment you have sulfide combining with this, it gives a violet coloration and it leads to the formation of a complex like this. So organic as well as coordination compound. So in both of these chapters, this is quite an important question. And who gave us the right answer? Unfortunately, nobody were able to give us the right answer. Yogesh, Sakshi, and Peru, who has joined us, didn't give us the right answer, guys. It is definitely option B. It is Na2FeCnNO. So it's a nitrogen based coordination compound and its relevance is in organic chemistry as well. So let's get going. The fourth question packed for today. In the coordination compound K4 NiCN4, that's potassium tetracyanonickelate, oxidation state of nickel is, quickly, these are questions that are packed for you guys to recap your concepts really fast. So get going with this, guys. Shouldn't take you a minute's time as well. 45 seconds is too much. You should be able to solve 2 questions in that 45 seconds time period. So get going. In the coordination compound K4 NiCN4, oxidation state of nickel is, Shakir, waiting for your answer as well. We have Surabhi joining us. Welcome to the webinar, Surabhi. Get going with this question. Another 5 seconds left, which is more than enough to quickly give us the answer. The calculations have to be done mentally. What is it? K4 NiCN4 times. What is the coordination oxidation state of nickel? Yogesh says it's a C. Peru says it is B. Guys, it is pretty straightforward. It is pretty straightforward. You shouldn't fumble here. Look at it. If I have K4, the charge on each potassium is +1, which means charge on 4 potassium is +4. Why is this given? This is the counter ion, which means that the charge on NiCN4 is 4 minus. Therefore, take the algebraic sum. Nickel X cyanide is minus 1 into 4 minus 4, which is equal to minus 4. Therefore, X has to be equal to 0, which is option B. So Peru and Sakshi Pandey were able to give us the right answer. Guys, it's again pretty straightforward. If you don't want to do it so much, there's plus 4 outside and there's minus 4 outside. Therefore, the charge on nickel has to be 0. So good, Sakshi and Peru. Yogesh, hope you have followed. Surabhi, who joined us, I hope this question has made sense to you. Let's get going to the next question. Oh, good. This is a quick breather for you. And Shakir says it is D. I hope you have understood as well, Shakir. The previous classes contest question, guys, I picked it up from the that is the previous class. In spectrochemical series, chlorine is above water. In spectrochemical series, chlorine is above water. This is due to, so spectrochemical series is the arrangement of ligands in the increasing order of their capacity to split the d orbitals. So that's spectrochemical series with respect to crystal field splitting. So the answer was good pi acceptor properties of Cl, strong sigma donor and good pi acceptor properties of Cl, good pi donor properties of Cl, and larger size of Cl than H2O. Think, what is spectrochemical series arranged? Spectrochemical series is arranged based on its capacity to split the d orbitals into two different layers. The larger the splitting, the better it is as a ligand. So based on that, it has to be a very clear cut answer. You have more questions to do on this topic in today's class, and before that, I take great pleasure in telling that Preeti has not joined us today, but Preeti has given the right answer, guys. So congratulations, Preeti, you have won yourself an atom session. So good, it gives you an exclusive right to get either a question or concept of yours answered by our in-house experts within 20 minutes of posting the question. So let us not waste too much time, guys. We have a good number of questions packed for you. And for people who are eager to know the answer, guys, it's a option is X, strong sigma donor and good pi acceptor properties of Cl. Like I said, we have quite a few questions packed, and it shouldn't be a problem to guess why chlorine lies above water in the spectrochemical series, because it's pretty straightforward. What is the work of a ligand? The work of the ligand is to split the d orbital. There are 5 orbitals. To split the d orbitals into 2 levels. On what basis will it divide? Based on its negativity. If it is going to be based on its negativity, which is going to be more negative and which is going to be less negative or neutral, it has to be chlorine and H2O. Therefore, strong sigma donor, which means it can pull the electrons towards itself, and a good pi acceptor, which means it can even still accept the pi electrons as well. So chlorine takes the top position here with respect to electron taking capacity. When it takes electrons better, its negativity increases. As its negativity increases, its capacity to split the degenerate d orbitals increase. Therefore, option X has to be the answer. Congratulations once again, Preeti. And Peru has asked us for the answer. I hope you have understood and listened to the explanation. And let us get going, guys. Let us get going. So here it is, Preeti. And the next question is here. guys. Hope you guys have answered the question. Let us get going with the question packed for continuation of this program. The IUPAC name of CONH3 6 times Cl3 is. Again, it's a pretty straightforward nomenclature based question. So let us have a detailed look at it. Hexamine cobalt 3 chloride, hexamine cobalt 2 chloride, triamine cobalt 3 chloride, and none of these. Which one is going to be the right option in this case? Which one has to be the right option in this case? Shouldn't take us too much time, guys. Shouldn't take us too much time. Get going. Get going, guys. Clockmaster says time's up. I'll give you a couple of more seconds. Fifth question and the option. And I request Shakir, who has joined us through YouTube, to prefix your question. To prefix your answer with the question number. So we are looking at the fifth question. So mark your answer as 5A, 5B, 5C. That way I'll be able to understand your answer better. Hope you have followed, Shakir. And Sakshi Peru gives us the answer first, followed by Sakshi, Yogesh. So all of them say A. Yes, you guys are right. I've kept it pretty straightforward. Hexamine cobalt 3 chloride. The counter ions. Here you have the counter ions. Charge is -3, which means overall it is +3. Amine is 0. So cobalt is present in +3 oxidation state. 6 amines. That's hexamine cobalt 3 chloride. Good. Let us get going. Look at the sixth question, guys. The coordination number and the oxidation state of element E in the complex. I hope what E stands for in this. En stands for what? Ethylene diamine. So I've given you a slight clue. En stands for ethylene diamine. And E is an element. You don't really have to worry about which element that is. Using the other ligands that you have associated with this compound, you should be able to answer this question. So go for it. E, En, C2O4. C2O4 stands for oxalate. You just have to worry a little about the charges on these ligands. The moment you know the charges on these ligands as well as the charge on the counter ion, you should be able to give us the answer. So Clockmaster says time's up. So go for it. Peru, Sakshi, Yogesh, Shakir, go for it, guys. Go for it quickly. Coordination number and the oxidation state. So what is it going to be? Sakshi says it's 6B. Okay. Let us wait for others as well. Yogesh also says it's B. Shakir says it is D. Pretty straightforward, guys. Pretty straightforward. The moment I write the algebraic sum equation, you will be able to give us the answer instantaneously. So let us wait for Peru as well. Peru says it is C. Let me give you the algebraic sum. So we don't know what is the oxidation state. That's what exactly we are supposed to calculate. X plus ethylene diamine, that is the didentate ligand. Its charge is 0. And oxalate's charge -2 is equal to 0, which means X is equal to 3. So X plus 0 minus 2 minus 1. So X has to be equal to 3, and if X is equal to 3, it means 6 and 3. Look at it, guys. Look at it. Peru is right. We are asking you the coordination number and the oxidation state. The coordination number should be pretty straightforward. It is 6 and the oxidation state is 3 according to the simple algebraic sum. You should have just recalled the charges on the ligands. It should have helped you guys. So hope you have understood. Proceeding ahead to the seventh problem. In AgCN twice 2 minus. That's AgCN twice minus. It's a silver and a cyano complex. Okay, Sakshi has asked me to repeat that question. We'll get back to that, Sakshi. Work on the seventh problem. We'll get back to that. It's a simple algebraic sum. I'll help you with that. So look at this question right now. So it's a complex of cyanide and silver, the number of pi bonds is, you just have to break the molecule and you'll have to look at the molecule at atomic scale. Once you look at it at atomic scale, you will be able to tell the number of pi bonds. So work on it, work on it. So Shakir, Sakshi, Peru and Yogesh. So Shakir has given us the answer for the previous question, but then looking forward for the right answer in this question, guys. Go for it, go for it. Yogesh says it is 7C. Let us wait for Peru and Sakshi along with Shakir. Quickly. AgCN2 minus. So what is it going to be? Pi bond. Sakshi also says it's C. Explain the seventh question is what Shakir is asking. So yes, I can definitely explain it to you. Sakshi, I'll get back to the previous question. Before that, let me quickly explain this question to you. We are asking how many pi bonds are there. To know the number of pi bonds, you just have to break the molecule, guys. You just have to break the molecule into atomic scale. So let us say you have Ag and there's a simple bond. There is cyanide, and you should know cyanide is nothing but C triple bond N. So there are 3 sigma bonds, that is 3 covalent bonds, out of which one is sigma and 2 is pi, and another C triple bond N. Therefore, what should be the answer in this case? Pretty straightforward. There's 1, 2, 3 and 4. There are 4 sigma bonds, and all of you have given the right answer. Hope you have understood, Shakir. So good. Let us get going. Let us get going. And you'll be really glad to know that these questions have appeared in some of the previous year's question papers. So that's exactly why we have picked questions based on those questions, which will give you an overview as to what kind of questions are normally asked. So if you get questions like these, it is cakewalk. So you can use the rest of the time to answer questions from other chapters. So get going. The IUPAC name of CONH35NO2Cl2. What is this going to be? Quickly. What will be the IUPAC name of this? Pentamine nitrito cobalt 3 chloride, pentamine nitroso cobalt 3 chloride, pentamine nitro cobalt 2 chloride, none of these. So IUPAC nomenclature have increased because Preeti, who had joined us in the last class, and another student whose name I forgot, had asked for some questions to do with IUPAC nomenclature because that was periodically repeated. That's exactly why I've packed a little more questions based on IUPAC nomenclature. So go for it, guys. Go for it. Try to answer this question. Yogesh says it is C. Okay. Shakir says it is B. Peru, Sakshi, go for it, guys. Go for it, go for it. Sakshi says it is C. And Peru also says it is C. It's quite astonishing, guys. It's quite astonishing that you guys are able to answer the difficult parts, but then you guys are missing out on nomenclature aspect. So it is pretty straightforward. It has to be option A. Why is it option A? Amine 5 times. That's pentaamine. And you should know that it is not nitro, it is nitrito. When it comes to coordination compounds, NO2 becomes nitrito. That's exactly why we have packed questions like these, so that you get to know the nuances of the differences between nomenclature of organic and coordination compounds. So NO2 becomes nitrito and ONO becomes O nitrito. That is, the bonding happens through oxygen. So O nitrito. So remember, hope you will not forget this henceforth. So it is not nitro, it is nitrito cobalt 3 chloride. How do I get to know that it is cobalt 3? Simple. Chlorine is -2, which means the overall charge is +2. Why is it +2? Because cobalt is unknown and on nitro group it is -1. So x -1 is equal to +2. So x is equal to +3. So it is cobalt 3 chloride. Hope you have understood, guys. Nomenclature, you guys have been disappointing me a little, but hope you guys will quickly make it up for me in the questions that is about to follow. So pentamine, nitrito, cobalt 3 chloride, quite an important chapter, and the best part is nomenclature will fetch you very easy marks. So hope you don't do mistakes in this aspect. And Shakir also says it is C. And we have Roshan Kumar joining, and Shakir says B, and Roshan Kumar says it is C. Hope you have understood, Shakir and Roshan. Hope this aspect of nomenclature has been in-depthly taught to you, because I've been looking at it from the day 1 class of coordination compounds. So get it right, guys, get it right. Moving on to the 9th question packed for today. Get going, guys, get going. The pair of compounds in which both the metals are in the highest possible oxidation state. So we are asking you to calculate the oxidation state and check which of the pair of compounds will have the metals in their highest possible oxidation states. All that you have to do is a simple algebraic sum. So it shouldn't take us more than 20 seconds. I can prove it to you, guys. I can prove it to you. So get going. Option A, option B, option A iron and cobalt, B chromium and manganese, option C titanium and manganese, option D cobalt and manganese. Clockmaster says time's up. I can give you a couple of more seconds, but I want the right answers, guys. I want the right answers. You are capable of doing it. Go for it. So a pair of compounds in which both the metals are in the highest possible oxidation states. Yogesh A, Peru B. Let us wait for Sakshi. Meanwhile, Roshan and Shakir has given us the answer. Both of them say it is B. Okay. Sakshi also says it's B. Yes, 4 of you are right. Unfortunately, Yogesh was not able to give us the right answer. It is indeed option B, because chromium oxygen is -2. -2 into 4, -4, and Cl is -2. Therefore, chromium is in +6 oxidation state. And manganese is in +7 oxidation state. That's because x minus 8 is equal to -1, and x is equal to -1 plus 8, which is +7. I can calculate others as well for you. So this is +6, +7 here. Iron here is in, I can say x minus 6 is equal to -3. Therefore, x is equal to +3. Cobalt here as well is in +3 oxidation state. Titanium here is +6. Because oxygen is -6, titanium has to be +6, and manganese is, my oxygen is -4, manganese is +4. That is simple. You have to maintain the overall molecule neutral if it is not an ion. So on that basis, here again cobalt is +3, manganese is +6. So maximum possible oxidation state, you should know that chromium 3d5 4s1, I can get rid of 6 electrons. Therefore, maximum oxidation state +6. Manganese 3d5 4s2, I can get rid of 7 electrons. Therefore, maximum oxidation state is +7. Hence, option B is the right answer. So good. Others who are thinking that cobalt and iron, which was the answer, that is Yogesh. Hope you have understood, Yogesh. So let's get going. We have Miss Vaishnavi joining us. Welcome to the webinar, Vaishnavi. So get going. We are moving on to the 10th question packed for today. So get going. 10th question. The coordination number of the central atom in a complex is determined by. So always beware. Whenever you have solving type problems, you can do it in a jiffy. But whenever you have theoretical questions, you should give it a little time. So read the question in a very detailed fashion, so that you'll be able to ask questions if you have any, guys. The coordination number of a central metal atom in a complex is determined by the number of ligands around a metal atom bonded by sigma and pi bonds both, the number of ligands around a metal ion bonded by pi bonds, the number of ligands around a metal atom bonded by sigma bonds, and the number of only anionic ligands bonded to the metal atom. So you just have to give it a little thought. We are talking about central metal atom, we are talking about ligands. What really is the connection between the two is determined by these statements that we have given here, and we are asking you the right answer. So go for it. So Shakir has already given us the answer. Roshan Kumar, I guess he has not prefixed the question, but he says it is D, which means I'm assuming it is for the 10th question, Roshan. So Roshan says it is D, Shakir says it is C, Peru also says it is C. Let us see what it is. It's matching. So the number, Sakshi also says it is C. Let us wait for Yogesh, and we have Vaishnavi who have joined us just a couple of seconds ago, minutes ago, I must say. So let us wait for Vaishnavi's answer as well. So give me your answers, guys. Let us see what it is. Number of ligands around the metal atom bonded by pi bonds. So let me tell you, most of you have arrived at the right answer. The number of ligands around a metal atom bonded by sigma bonds is called the coordination number. Pretty straightforward. You just have to make yourselves aware, and you have to stay abreast with couple of very basic definitions as to what is coordination number, what is a ligand, what is coordination sphere. These things will help you in indeed answering questions like these, which carries 4 complete marks. It is number of ligands around a metal atom bonded by sigma bonds. So most of you have given me the right answer, Yogesh and Pooja. Let me know if I can help you in any way. It's a simple definition based problem. See, if you want more explanation, I can help you with it, guys. I can help you with it. So Shakir good says C, and Roshan says D. No worry. No worries, guys. I hope you guys have understood. What is coordination number? Coordination number refers to the number of ligands present around the central atom bonded by sigma bonds. How are these sigma bonds formed? By sharing of electrons. So that's about the 10th problem. Moving to the 11th problem. So get going, Pooja, Yogesh, Sakshi, Peru. Get going, guys, get going. Shakir and Roshan, Vaishnavi as well. Numerical problem 11. So just a couple of more questions packed for you in today's session. And mind you, guys, we have another session packed for you exclusively within 15 minutes of completion of this session. So you have to stay in tuned with HashLearn to get back-to-back questions based on coordination compound and a thorough in-depth understanding of whatever is happening in today's class. So EDTA has coordination number. Quite a favorite question for most examiners. EDTA, coordination number, or EDTA structure, or what is the denticity of EDTA. So we have quite a few questions always arising on EDTA, which I have asked you as well. So Shakir has given us the answer already. Shakir says it is option D. Yogesh says it is A. Guys, remember one thing in mind. Answering new type of question is a task, it's a challenge, but then keep one thing in mind. There are certain fixed questions when it comes to chapters which you have to know at any cost. So I would advise most of you to solve previous year's question papers, which we will be starting very soon. In the month of December, we will be starting covering it at depth exclusively for you guys. So I would always suggest that it is always good to look at the questions that have been previously asked, so that you will know it at what range or at what level the questions might be expected in the forthcoming examination. So that is one aspect which I want you guys to dwell on. So have a look, and if you have failed to understand, or if you feel it's going to be a little difficult for me to understand, stay tuned. We have a packed session based on previous year's question papers packed for you guys. So not delaying too much, let us take the answers that we have received. Yogesh A, Surabhi says it's B, Sakshi says it's D, and Pooja also says it's D. On the other hand, both Shakir and Roshan says it's D. So let me give you the structure. Based on the structure, you should be able to give me the answer. I'll give you a little modified structure. The structures are either ways right. We'll see how it goes. So it's simple. C double bond O, CH2, N, CH2. I will show the structure in such a way that you will know why it is the respective ligand. So CH2, C double bond O, and then there is O minus here, O minus here, and to this nitrogen you have a CH2 molecule attached. So it is C double bond O, O minus, and there is another O minus here, O minus, C double bond O, and connecting both of these is CH2. Now see where the electron pairs are coming from. So there is a lone pair on this nitrogen, therefore nitrogen will donate its pair of electrons, this oxygen will donate, there are two oxygens, and these oxygens will donate as well, which means it is going to receive 6 pairs of electrons. If it is going to receive 6 pairs of electrons, how many coordination bonds is it going to form, or what is going to be the coordination number? It is going to be option 6, I mean that is option D, answer 6. So good, Sakshi, Pooja, Peru and Shakir were able to give us the right answer. If you feel that this structure is complex, the structure was drawn in order to show you how the complexation happens, so that it helps you in answering questions like chelation, etc., etc. But if you feel that you need a more simpler structure, I can give you a more simpler structure as well, guys. What does EDTA stands for? EDTA stands for ethylene diamine tetraacetic acid or tetraacetate ion, ethylene diamine. So all that you have to do is, see, you have nitrogen and ethylene diamine. So I can show it to you this way. CH2, CH2, ethylene. So diamine, amine is NH2 and NH2. All that you have to do is remove the hydrogens here. So I've removed 2 hydrogen. Instead of 2 hydrogens, I will pack the acetate. So that is CH3, C double bond O, O minus. That is CH2, I'm sorry, CH2, C double bond O, O minus. So same thing here, CH2, C double bond O, O minus, and CH2, C double bond O, O minus. So there are 4 pairs coming from these minus signs, and there are 2 lone pair present on nitrogen, which can also be donated. Therefore it is a hexadentate ligand. This was shown to prove the chelate formation, and this is the simple way of writing EDTA molecule. Hope you guys have completely understood this question, guys. So quickly proceeding to the 12th question that we have packed for today. Have a detailed look at it. So we are asking you, which of the following configurations can undergo distortion? Which of the following configurations can undergo distortion? So have a detailed look at it. Just another question. So I had packed 13 questions for you, and looks like all of the 13 questions were equally interesting and enthusiastic. So go for it. Which of the following configurations can undergo distortion? So have a detailed look at it. So what is, or which of the following configuration is undergoing distortion and which will not undergo distortion is the question under discussion. So have a detailed look at it, guys. So which one is it? Yogesh says it is option B. Shakir says it is C. Okay, let us wait for Pooja, Sakshi, Surabhi and Peru to give us the answer. Meanwhile, also Roshan. So give me the answer, guys. I'll give you a slight clue. What is this distortion based on? Simple. If the arrangement is symmetrical, imagine you have a symmetrical arrangement like this. Therefore, the ligand approaching from all directions will be repelled equally. So symmetrical distribution of d electrons, they're all repelled equally. Therefore, if you are expecting for distortion means asymmetrical, it is asymmetrical distribution. And asymmetrical distribution, just like you guys know, asymmetrical distribution leads to unequal distribution as well as unequal repulsion. So which one is that which shows distortion? Because of the presence of unequal distribution of electrons. Guys, it is pretty straightforward. The one which is unequally distributed is option A. You shouldn't be forgetting that what is T2G level and E2EG level. T2G is if you have 5 orbitals in the D, that is 5 orbitals in the d subshell, they will be dividing into 2 phases, that is 3 orbitals into one level and 2 orbitals in the other level. So the lower orbital will be called as T2G and the above orbital will be called as EG. So if you look at uneven distribution, if you look at this, there will be 6 and there will be 2, almost symmetrical. There will be 6 and there will be 4, again symmetrical. 6 and 0, almost symmetrical. 6 and 1, so you'll have it like this, and 1. So this has higher amount of asymmetry associated with it, therefore it has to go maximum, or it has to undergo maximum distortion. You just have to remember one thing. Questions like these are quite important. So if you want to know what is distortion, configuration distortion is how the shape is going to change based on the number of electrons. It has to be symmetrical. That is, if the T2G level is half filled, EG level also is half filled. T2G level fully filled, EG level also is fully filled. Or T2G half filled, EG full, T2G full, EG half. This is how it is going to be symmetrically distributed. That is how it is for all of these. But when it comes to option A, it is 6:1, which is not at all symmetrical. Therefore, that is undergoing maximum distortion or distortion, if any, and hence option A is the answer. Hope you guys have understood, guys. Remember this, quite an important aspect. Moving on to the last question packed for this session. The last question is, unfortunately, nobody were able to give us the right answer, but I hope, previous question I'm talking about, I hope it has made sense to you. Look at this question. Let us not waste time dwelling on the previous question. I am quite sure you guys have followed it. The oxidation number, the orbital occupation, and coordination number of chromium in the complex cis chromium, ethylene diamine, dichlorido, chlorine are respectively. All that you have to do is you have to try to look at that complex. Based on that complex, three simple things are asked: oxidation number, the orbital occupation, and coordination number. So what is asked? You have to try to understand. Oxidation number, d orbital occupation, and coordination number. So let us look at the oxidation number first. Chromium X plus 2 minus 1 minus 1 is equal to 0. Therefore, X is equal to plus 3, which means chromium is in plus 3 oxidation state. So chromium is in plus 3 oxidation state. So once I get to know that, it is simple. Ethylene diamine is 0. So chlorine is minus 1 into 2, and this is another chlorine which is minus 1. So chromium is in plus 3 oxidation state. So chromium plus 3 is, so plus 3, this is plus 3, this is plus 3, and this is plus 3. So this can be ruled out. The next is d orbital occupation. Chromium outermost electronic configuration 3d5 4s1. Therefore chromium plus 3, remove 2 electrons, that is 3 electrons, I'm sorry, it becomes 3d3, which means it is in 3d. So 3d, so remove this option. It is plus 3 plus 3, 3d and 3d. Now the computation is between option A and C. Next is coordination number of chromium. Coordination number of chromium depends on the denticity. You need to understand that ethylene diamine is a didentate ligand. Didentate ligand. So that is, it is giving 2 donor atom, 2 electron pairs. So 2 into 2, 4 electron pairs, plus chlorine. There are 2 chlorines, so 2 into 1 electron pair. So that is again 2 electron pair. So how many electron pairs in total? 4 electron pair and 2 electron pair. 4 plus 2, that is 6 electron pair. If there are 6 electron pair, it means it will form 6 bonds. Therefore, coordination number has to be 6 in number. So it is plus 3, 3D and 6. I hope you guys have understood. So Peru gives us the right answer, Yogesh gives us the right answer, and I think people are working from your end. Let us quickly see. Shakir initially said it is A, Roshan says it is C, and Shakir also later on says it is C. So Shakir has asked with the daily life classes. Yes, Shakir, you will definitely have live classes on a daily basis. All the 4 subjects PCMB will be taken care of. Guys, this is the last question. Like I said, it has been packed. You have a short 15 minutes break, a quick breathing time, and the next session of mine will probably start in less than 15 minutes. That's the second session, which will be looking at coordination compounds. That's the last but second session, which will be looking at coordination compounds. And I hope you guys have understood the questions that we have looked at. Like I said, we have looked at the bonding aspect along with the cumulative study of whatever has happened in the previous classes. And today's class was really interesting. You guys made it really interesting and enthusiastic for me. Hope the feeling is same from your end as well. And people who have joined us through YouTube, join us through the HashLearn app. That way you will get to interact with a lot of fellow students of your age, wherein your understanding horizon will broaden, guys. So hope to see you guys in the next session of mine as well. Till then, it's your chemistry teacher Dheeraj signing off. See you soon.